Hi, and welcome to this episode, number 62 of the eBPF and Cilium Office Hours live stream. If you are watching us from wherever you are around the world, then do drop us a comment, say hello. Feel free to ask questions throughout. We're always keen to hear what it is that we can help you with and what you would like to know. So today, let me just bring up my screen, and the highlight today is going to be a recap of the BPF and Networking Track at the Linux Plumbers Conference. Before I turn to that, I will just quickly mention the eBPF Summit. We are less than 2 weeks away from eBPF Summit 2022. It's happening on the 28th and 29th, which is Wednesday and Thursday, not next week, but the following week. So please register, join the Slack channel, let us know that you're coming. It's going to be a really great agenda. You can scroll down on this page and you will find all the details about the schedule, which is all live, and you'll see how many amazing talks we're going to have on those two sessions, 2 days. So that is pretty much the only headline that I have for this week, because most of the rest of the show is also going to be about BPF related news that has come from the Linux Plumbers Conference. So let me bring into the stream Daniel Borkman. Thanks for joining us, Daniel.
Thanks for having me.
So you and I have both been in Dublin this week, but we managed to not bump into each other.
It was very busy.
I was there for the Open Source Summit, which is organized by the Linux Foundation, and you were there for the Linux Plumbers Conference. So maybe tell us a little bit about what Linux Plumbers is and who goes.
Yeah, so the Linux Plumbers Conference is essentially a developer conference. A lot of the kernel developers go there to meet up and discuss specific topics. Not only kernel developers, there's also user space side, like all the toolchain folks, such as compiler developers around GCC, LLVM, also systemd. So it's also like a little bit higher up in user space, all the system tooling folks. And Linux Plumbers Conference, it has a number of regular talks that are being presented, but the main goal is to get the people together to sit in a room to discuss certain topics. Maybe there has been contention somewhere on the mailing list, and people got stuck because they have different views or opinions on a specific change. So the idea is to get them in the room and figure things out, how to move forward with that. So it's very much about ongoing development topics.
Just going to quickly say hello to a couple of folks. Hi to Kyung Chol from Stockholm, and hello to regular viewer Russell. Thanks for joining us. Anyone else out there, please do feel free to let us know where you're watching from. So who organizes the Linux Plumbers Conference, and how do the tracks get chosen, and then how does the content for those tracks get organized?
Yeah, so it's organized by the community in general. So the Linux Plumbers Conference is, like the high level organization is done by kernel folks, and they do this voluntarily in their spare time. There are a number of, like the Linux Plumbers Conference, there are a number of sub-tracks, such as micro-conferences. Those micro-conferences are around specific topics. One, for example, that is quite popular is Rust in the Linux kernel. So, people are talking about open topics there, or there are a number of others as well, such as, confidential computing, Android, RISC-V, so and then those micro conferences, they are usually organized by either some maintainers for those subsystems or core folks that are involved in that. They are usually half a day. They have a specific agenda. There, a lot of topics are being covered there. Then there's also a networking and BPF Summit track. So we organize that. Essentially, the committee there all the maintainers for the networking subsystem and the BPF subsystem in the Linux kernel. And we help run the track. We announce the CFPs. We define the format, how this is done, and we also vote among each other what talks we want to accept, and then we set the agenda and schedule, and then moderate, right? So everything, essentially, yeah.
So I'm just going to bring up the agenda here for the BPF and networking track. But one other question before we dive into that: who attends, and can anybody attend?
Yeah, so the Linux Plumbers Conference is open for anyone, and usually when they announce that tickets are now available, you really quickly need to get them because they sell out easily. So it's usually restricted to around 500 people in person. And, there are a lot of developers that are going there. So they usually sell out within 2 days or 3 days. So you really need to be fast to get in. But in general, it's open for anyone. And, so also newcomers, they are definitely welcome to join and participate. And it's really great because you can talk to, even folks that have been in Linux kernel for more than 20 years. They are just in person there and you can talk to them. So, yeah.
That's great. We'll just say greeting to Buna, Susie, and to Tim. So thank you both for joining us and saying hello. Okay, so the BPF and networking track seems like it's a pretty... well, I'm guessing just from the fact that it goes over 3 days, it must be quite a substantial size track within the whole of Plumbers. Is it the biggest track, or how does it?
I think it is the biggest track, yeah. And actually, like those submissions that we got, it was really hard to figure out which to choose because we got so many great submissions. And half of the submissions we actually had to reject because it wouldn't just fit. Originally, we had like a single session planned for 40 minutes, but then, to fit more content, we shortened it down to 30 minutes, which I think is, more than enough to get an overview of the content and some initial discussion going. But yeah.
And then does it quite often turn into an ongoing discussion on the mailing list or somewhere else after the event?
Exactly. I mean, like the event also has a good number of breaks in between, to recover from all the content that you brief in, but also, as a hallway, it's also important to talk people like to folks in person in the hallway, and then a lot of the discussions they continue there as well.
Hallway track is always the best track.
It's the best.
So Russell's asked a very good question, and one that I know the answer to. So will the talks be available online? We were just looking at how they are already. If I click on this.
It's a great question. Yeah, exactly. So the whole event was live streamed, and today in the morning, I put all the sessions from the raw video streams already online. So you're able to watch them.
So it's really like a community event in the sense that there's no producers doing that uploading for you. You're doing that as well.
Exactly.
So you're presenting at the conference, you're organizing the track, and you're doing the video uploads. That's amazing.
It's community run,
Excellent.
Yeah.
Okay. So maybe tell us just a little bit about like the difference between this conference and there's another kind of set of Linux and BPF conferences that I think are more invitation only. Is that true?
Yeah, exactly. So there's also one that is BPF related, which is called LSF BPF. So that's a conference around kernel developers for, everything Linux storage, memory management, and deferred, foundation for that is also BPF. That's invitation only. So, but usually all the core folks are being invited who contribute to the development. And the idea there is to get, let's say around 20 people into a single room, and it's more around discussion. So maybe like one session has around 3 or 4 slides, and the rest is, discussion. How do you move this topic forward? What are the blockers? you know, like, and Linux Plumbers itself, like the networking and BPF track, these days it's more around the presentations. So, I mean, we get a lot of good and different content in there, and it's a great medium to present to, you know, folks what is being developed today in the networking stack, what is relevant in the BPF side. It's a bit less discussion because, you know, time is scarce there, just 30 minutes. So it's some topics they need more than that, but you know, it's we essentially want to bring a lot of content in there and not just hash on one topic for more than 1 hour. So
right, so that
yeah,
would be
that's
the
why.
difference. That LSF
Yeah.
and BPF would be more of a let's focus on this until we've got the answer.
Exactly.
Right.
Exactly.
Okay.
I think both are needed as a medium for people and developers to come together.
That makes sense.
Yeah.
And amongst all the things that you were doing at this conference, you gave a talk yourself.
That's true. So it's been really busy. Yeah, I gave a talk around some of the things that we're doing around Cilium. One of the topics that I've been working on, you know, a couple of months before the conference is to rework the, you know, the main data path that Cilium uses in the kernel.
I've realized that before we moved on to your track, we were going to quickly just dive into a couple of slides that Alexei presented. So I think he had the opening talk from the track. We can see it here. And we were just looking at a couple of slides before we came on air, and there's some really nice things in here about BPF enabling innovation. So, and I think that kind of reflects very much how I feel about, you know, eBPF allowing us to have, you know, changes in the kernel that not everybody has to take. And that I did a talk at LSF Summit about how eBPF allows us to remove sidecars, or we can have different options other than sidecars. And it doesn't mean to say that like everybody has to, people can still carry on using sidecars. They can choose whichever model suits them. We can choose. I think eBPF is giving us a lot more choice in the kernel, which is really nice. And then there's also these really great graphs, which I think show how much like activity there is in BPF. I mean, this goes back to April 2019. So I guess this is just over 3 years worth of emails on that BPF mailing list. And
it probably would have been good to go even back further to 2016 or so, but you know, like it's been growing like crazy. And these days, you know, on the BPF kernel mailing list, there are between 50 and 70 emails every day that, you know, maintainer and reviewers, they have to go through and they have to, you know, reply and give direction whether the change makes sense or whether something has to be fixed before it can be merged. So it's really super busy.
and that takes quite a bit of your time personally as well, I imagine.
That's true. Yeah, every day. Yeah.
So, you know, you're a big part of this gap here between Meta and everyone else. You're probably a good proportion of that.
That's true, yeah. And it's really great to see so many new people joining the community. So now we are, you know, the number of different developers has been growing now to roughly 120, which is great because it really makes the, you know, people are solving their use cases with BPF. They need to make a kernel change or improvement, and they contribute to it. And that's really awesome to see because it helps the whole subsystem to grow.
Fantastic. All right. So I think we should now turn to your talk. You were about to tell us about this, and remembered we wanted to talk about that overview. So tell us a little bit about the background to this particular talk.
So the background was actually an outage from a user environment. Luckily, this was just in a staging environment, so not as bad. But we had an incident where in Cilium, you know, a user reported that suddenly pods couldn't connect to each other. Some could, but some in the cluster couldn't. And we tried to figure out what was going on, but it was really tricky because, you know, like from the agent perspective, from Cilium, everything looked normal. we took a system dump, which is like a program which is executing various things like getting all the IP addresses, the routes, the layer 2 addressing, and all this kind of information for us to analyze to help troubleshoot. And everything looked normal. Yet there was a connectivity issue. And then at the same time, that user had another cluster with the same Cilium version, same configuration, everything was running smoothly. So we figured out what was going on in the end, and thanks to BPF tool, actually. So BPF tool is able to dump all the BPF programs that are attached to a specific location. And when we looked at what was attached to the networking devices that Cilium creates, suddenly there was a BPF program that we didn't expect. And when we looked for the potential source of that program, we saw there was a third-party agent, and that third-party agent was exactly attaching to the same location and then, removing the Cilium programs underneath us. And the agent didn't realize it. And yeah, that's why also the logs looked okay from that perspective, right? So it was really like a problem of ownership. And the work that I've been doing over the last couple of months is basically to implement something that is called BPF Links for the TC layer, like for the TC BPF layer, which is the layer where the main forwarding of network packets happens inside Cilium. Where we do all the policy, where we do the load balancing, where we implement all these features. And it has been a bit tricky because like the TC BPF side has a different object model, which doesn't quite fit to BPF Links. I should probably first talk a little bit about what BPF Links are in general.
Let me know if there's a slide you want me to bring up.
Yeah, there is. It is in the second section in the part 2, so we have to scroll further down.
Looking for part 2. Here we go. Part 2 is here.
Yes. So. Probably a bit further. I think maybe this one, or yeah.
Sorry, what? This one maybe? No.
Yeah. I think that's fine. Yeah. Could you make it a bit bigger? That probably helps. So anyway, yeah. So BPF links are like objects like BPF maps or BPF programs. I mean, they're in the same kind of category. And what a BPF link is essentially an abstraction of a program that is attached or that is to be attached somewhere. And a BPF link basically contains a BPF program. So it holds, inside the kernel, it holds a reference count to the program so that the program just doesn't go away. And then you can attach the BPF link somewhere. For example, in case of tracing, you can attach a BPF link to a K probe or to a U probe. And it resolves two things, right? One thing is to ensure that, when the application exits, that the whole BPF link in this attachment thing that, like, depending on where it is being attached, gets cleaned up properly. That's one thing. What you can also do with the BPF link is, to pin it inside the BPF file system. And then when the process actually exits, which created this, the BPF program still stays alive in the kernel. This is not always...
interesting. So you no longer need the user space
exactly.
to kind of hold on to the file descriptor.
And this is not given for all the program types, right? For example, in case of tracing, you're working with a file descriptor. And when your process exits, also the file descriptor gets cleaned up by the operating system. And that BPF link thing, that small, let's say, container around that BPF program keeps it alive. And once when the application comes back up again, it can grab the ownership again of that BPF link, and it can continue to use it. That's essentially what you could do with that, is to upgrade your application, restart it, and you're still the owner of that program that was originally installed.
Okay.
So yeah, it is basically an abstraction of the program plus the attachment where the program is being attached to.
Okay. And would that affect the number of, I don't know, could you do things like attach the one program to multiple attachment points or have multiple programs attached to one?
So the BPF link is usually like a one-to-one relationship.
Okay.
In case of tracing, there was actually an interesting talk given by Jerry from our team, where he, where he attaches, a K probe to multiple locations. It's a different topic, but there's also like a BPF link for it, so that you can manage to upgrade that BPF program atomically and in a really fast way. For example, that's what we also use in Tetragon, where you're able to attach to, let's say, roughly 50,000 kernel functions. So many functions are in the kernel usually, and you can attach to all of them in less than a second. So that's the work that he's been doing. That is super useful. But yeah, also that, is managed through BPF Link. So BPF Link are really like and the BPF Links, they haven't been implemented for TC so far, because TC BPF, where we have all the networking data going through, has a different object model. They don't quite fit together because they're not file descriptor based. So it's, the question was, do we extend the TC internals and force, that attachment to not go away, which is really hacky, and there have been attempts in the past around this, or rather, do we rethink the whole networking TC layer, make it one, also more efficient, and two, allow for BPF links to live with that in a more natural way, in meaning that we have FD based attachment to that. And that's basically the work that I've been presenting and I've been doing over the last couple of months. So yeah.
Okay. So does that mean that in the future you won't be able to directly attach programs to hooks, or will you still have to, do you have to always use the link as an abstraction, or will you have the option to?
Yeah, so you always have the option. The idea is, like, there are production users out there that use the TC BPF layer as it is today. I mean, Cilium, we do it, but some may not be able to upgrade just from the old stuff to the new stuff. So they have maybe some programs still on the old style attachment in TC, and they're successively migrating. So there needs to be a path where you can support both. And that's also what my proposal has been doing, right?
Okay.
But, overall...
Sorry,
But, overall, like this BPF link then solves the ownership, right? So when we again have this kind of situation, you cannot override, or you cannot step on each other's foots, because the BPF link will prevent that. And that was one of the main reasons why we did that work.
Okay. So does that mean that the third-party program that maybe got loaded or attached rather after Cilium, that would get rejected, or that they'd be better able to coexist?
Yeah,
or?
It would get rejected. So only Cilium will be able to upgrade Cilium's programs and no one else. And at the same time, also, we cannot step on anyone else, right? So there is a certain way where you could allow coexistence if you, write your programs explicitly as such. But if there's no way, like if there, if a program thinks it owns the data path and it's maybe implemented by two different teams, and there's really no way of cooperation, at least you can make sure that you don't run in such an undefined state as we had in that incident. So that at least can be solved, right?
And without naming who the third party was, were they involved in the discussions of how this was going to?
I tried to reach out, but I haven't heard from them. So, but I mean, the infrastructure itself is generic and consumable by anyone, right? So it's a problem that we want to solve for a long time. And not only we as Cilium, I also heard from Facebook folks, they need the same infrastructure as well, because they have the same problem internally with their teams. They want to have this, guarantee of, first of all, ownership, but also of the cleanup. Because in their case, as opposed to Cilium, where we want to keep the BPF programs attached, even if the Cilium agent goes down, but we need this for upgrades, so that we can do upgrades from one Cilium version to another one atomically, where the data keeps flowing. The other case, at least the use case that has been discussed on the mailing list, also around from Facebook folks, they actually had an incident because programs where the application crashed for some reason, and then the programs that have been installed, they were left over, and because of that they had some kind of outage. So they want to have this clean way of removing programs again, and that also is solved by the BPF link work.
Brilliant. So that was the talk that you presented.
Yeah.
I know there were quite a few other folks from the Isovalent team, and you probably were quite involved with, the preparation around those talks and the kind of the topics that they were discussing. What are some highlights that you might want to tell our viewers about?
Yeah, so we are also developing a new BPF map. So that BPF map, so far we have called it, it hasn't been merged yet, but we've called it a wildcard map. That can be used for online packet classification. And the whole idea around this, or the use cases that we have for this map in Cilium, are actually threefold. So one is that you can have in general what this map is doing. It allows for a flexible way where you can specify a specific source CIDR, a specific destination CIDR, a protocol type like TCP, UDP, or anything. And then also port ranges. And you can then, get the tuple out of the packet and then look up the map, and then you see whether that matches somewhere or not. So it's a typical online packet classification problem. It hasn't been solved yet in BPF. The only way you could do this today is probably you would have like a decision tree that you would have to implement in BPF itself. But then again, BPF is limited, at least right now, to 1 million instructions by the verifier. So it may not be as generic as we would have liked it. And in case of Cilium, we actually have 3 use cases for that. One is a packet recorder. So on the XDP layer, we allow users to install, arbitrary rules, that can have specific CIDRs, ranges, and so on. And if they match, we want to, record this packet, how it's going in and out of the load balancer in a PCAP file. So we have a solution today, but it requires recompilation of the data path, which is not that great because, first of all, it takes long and it's also more fragile. The other use case we have is Kubernetes policies. So they have now made the port ranges as part of their specification, public and I think GA. So that would be a way to, for the policy mechanism to allow to insert arbitrary rules that you can then deny traffic on, right?
Okay, and you wouldn't have to write explicit sort of BPF instructions to say, look at this particular, byte in the packet that says what port it is. Yeah. It's going to take care of that for you.
Exactly, because it wouldn't scale. So let's say, for example, you have millions of rules, and you just cannot encode this into your data path, right? And the other thing is also you want to have a fast lookup, just like a few nanoseconds to come to a conclusion whether this is part of a given set of rules that you have or not. That is really hard to do otherwise. So yeah.
So I'm guessing that could also be like really efficient for things like firewalls.
Yeah, absolutely, yeah. DDoS protection, for example, when you have programs at the XDP layer where they get run as as early as possible, and then you want to have like a this kind of map in order to say, okay, I want to drop this packet right away because it's part of the set of rules that maybe there's an attacker. So you can implement something like that with this map. And we essentially looked at the different state-of-the-art algorithms from academia, and the fastest that is known today in terms of lookup time, but also in terms of update time. Lookup time has to be, that's probably the most crucial thing, to have smallest possible lookup time, but also the update rate where you can insert rules into the map. It has to be reasonably fast. We said at least it has to be a couple of thousands per second, but I think we are even much better than that. And what we found was that tuple merge algorithm is the best or like the most state-of-the-art known today. So my colleague Anton implemented that as a BPF map and also run some measurements with it. And it turned even out that the implementation is even faster than the existing LPM map that we have in the kernel today. So even if you just replace the two maps in your program, it will already get a speed up. But it allows for a lot of flexibility. So that's why I think it will be useful to a lot of people.
Fantastic. Any other talks from our team that you would particularly want to mention?
So my colleague Aditi, so she has been working on a feature that is called socket termination. That is essentially needed for, like that's a way where you can, from BPF side, kill a certain socket to force the destruction. Why do we need it? So for example, in case of load balancing, there's a TCP and there's UDP. UDP can be connected and unconnected. If you have something like connected UDP, then the way where like how we do east-west based load balancing is that like when there's a connect call, we look up the address and port and to see whether it's a match in the service table. And if it is, then we pick a backend from there right away. And we pass that down to the kernel, right? So essentially the BPF program has the view of what the application wants, and then it hooks into the socket layer, it rewrites that request, and then it pushes this down to the kernel, and the kernel thinks the application originally picked that backend, but actually the BPF program did it for us. And so why is this nice? Because we don't need to do like a per packet translation in terms of load balancing, right? So only like a rewrite of a structure in the socket layer. But one thing we noticed is for at least connected UDP, we need some kind of notification mechanism that a backend may be gone at some point, right? So Kubernetes has this feature which is called graceful termination. So it will notify through the Kube API server, for example, Cilium agent, given we listen to that, that a given backend is going away soon so that you have time to drain traffic away from it. That's also what we implement. But in case of connected UDP, you only, the application doesn't really receive the signal. So that's one solution. So like that's one area that we want to solve, that basically once we get the signal from Kubernetes side, then we iterate through all the sockets in the system. We see if that socket matches the given backend. And if it does, then we destroy the socket so that the socket is that the application no longer is able to send out the requests to that then becoming stale backend. Right?
Okay.
So you want to forcefully terminate this. And the feature was originally implemented in the kernel longer time ago because Android had a similar use case. I think it was, I have to remember the use case correctly, but I think it was when you roam around between different Wi-Fi's with your Android phone, you at some point when something goes away, you want to be able to destroy the socket so that you can recreate it and then to get connectivity back, something around this. And yeah, that feature wasn't available on the BPF side. And given we have iterators in BPF, which is, where you can iterate different objects, whether it's C groups, whether it's sockets, and at least for the socket one, that is interesting to us. So we wanted to have a way to then say, okay, this socket matches, and I want to destroy it so that it gets forcefully terminated. Yeah, given it's a slow path event, I think that is absolutely acceptable. And yeah, I think people also have agreed at the conference that is a good way to move forward with the proposal.
Okay, yeah. So this would be very much an idea that's at a sort of proposal stage. It's not in the kernel yet. So,
yeah. Okay. A lot of the talks, they are more around proposal stage to get everybody in the room onto the same context and into agreement. And it's a good way to also talk about use cases. Why do we need this change, right? It's an easy way to make other developers understand why you need a certain feature in the kernel, and then and then you gather feedback for improvements, and then you can include this into your patch series, and then you get hopefully accepted. Yeah,
makes sense. Just gonna throw on screen a comment from Nerd Deku saying, "I'm excited."
Me too.
We all are. Okay. So maybe we should just step outside of what's been proposed by Isovalent folks. What other talks do you think our audience might find most interesting if they go and check out that schedule?
I think overall there are a lot of interesting things going on right now in the eBPF world. In what is being developed. There are new use cases coming up with BPF. It's actually interesting how diverse they are. So some of them, they target, human interface devices for USB, for example, because they have quite they have a lot of devices and a lot of drivers out there, and a good number of those drivers, they're just doing the same thing. And sometimes devices might be broken in a slight, in a small way. For example, some key map needs to be changed, or there's some, I cannot really talk
physically broken,
like
I don't know, a wire is not
or like from the firmware side, or some of these things. And then you can use BPF to do some of the remapping, either around keys or if there's some drift from joystick and things like that, and you can use BPF to fix that up. And the idea is that those people who do those fix up, they don't have to patch the kernel for this. They just do the change in through BPF, and that way they can still submit this to the kernel, of course, but they can at the same time, they don't have to stay on a custom patched kernel that they use locally. Instead, they can just put this BPF program into some directory, into some sysfs directory or so, and still get the latest kernel with the latest stable fixes. So it's a much easier process. They don't have to wait until new kernels get released, and then they would include their changes, but they can just it's more easily do these kind of fixes, right? So that's one area.
Do you think that means that in the future, hardware manufacturers are going to be distributing, software updates or firmware
I think
updates
so, probably,
that are essentially BPF?
That could well be. Yeah, I agree. The other thing is also, I don't understand enough details about this, but it's also to implement a HID firewall through BPF, so that you disallow certain. Yeah, so that you disallow certain requests, right? I mean, a lot of these devices, it's similar to networking, right? Very similar. So they have messages they pass between each other, and you only want to allow a certain subset of them to make sure really nothing goes wrong. So yeah, it's actually really interesting to see these use cases and where BPF can be applied. The completely, like going from mice and keyboards and everything, back to data centers, right? So now there's a proposal actually from 3 different companies. So one is Google, the other one Facebook, and then also Huawei. They're all trying to implement a scheduler, like a process scheduler through BPF, so that you can basically, maybe some of the applications in the data center, they require specific scheduling policies, because maybe some applications, they are more, critical than others. So, they should be placed into different scheduling classes, and the idea is, to allow this customization inside the kernel with the help of BPF, so that, all these three companies, they have slightly different proposals. So one thing that needs to be agreed upon, and Linux Plumbers is a good venue for that, like the base framework that works for everybody, and then they can implement whatever they need in their systems, right?
So is this taking us in the direction of, I can't remember what the term is for this, but gradually implementing more and more pieces of the kernel in BPF, such that we will end up with the whole kernel being a whole set of BPF things glued together?
Yeah, that's pretty much into this direction, right? I mean, like all the core functionality, from the kernel will still be there, but all this customization that people need potentially doesn't have to go into the kernel. You can customize this all the way through BPF, and also roll it out more quickly, right? Like even for that. So just to give an example, right? I mean, Facebook folks, they implemented the framework where they can write TCP congestion control algorithms in BPF. So that already exists in the kernel today. And the idea is it allows more easily to experiment, because you don't have to rebuild your kernel. You don't have to roll out a new kernel. You can just change the BPF program atomically on the fly, and that's it. The same underlying kernel can just keep running, but you can at the same time more easily experiment and figure out what's the right way forward, what tweaks and in the parameters I need. And it's a lower barrier, and this is also what BPF enables there. The same with scheduling, I can imagine.
Russell's made a comment about the HID work and how it enables simple changes to the default USB HID driver without reload. Could be useful for complicated prototype HIDs. Yeah.
Absolutely. Yeah. So, that's one set of new use cases. There's more and different things discussed. For example, one is BPF signing. So that's an ongoing discussion also from the eBPF Foundation side. So the ideas, there are different problems, so signing is not an easy problem to tackle, because BPF allows, for all this flexibility. A lot of programs are created on the fly. A lot of things, they are fixed up, as we go. And if you would just have a signature around hard-coded BPF instructions, that will break 99% of use cases around BPF, right? So it's a tricky area.
That's a really great point. I had a similar conversation with someone around using OCI registries for potentially storing programs, which is certainly possible. Why not store a series of bytes in an OCI registry? That's fine. But you can't. Quite often you want to modify those programs on the fly, or you want many different versions that are slightly different to deal with, I don't know, different interface IDs or something that's just slightly different in each of those instances. So I can totally see how that adds a layer of complexity to a signing problem.
Exactly. And the flexibility here is really paramount, right? That we need, so that we don't break those existing use cases. So that's really critical, because the whole ecosystem depends on it. So right now, like the rough high-level idea is that we need some kind of gatekeeper BPF program that is, potentially part of the verifier, and that can be flexible. So, each distribution could implement their own potentially. There will be a reference implementation at some point from the foundation side, and the signature gets pushed down, as into the kernel, but allowing flexibility to the compile once, run everywhere mechanism, so that this gets then fixed up inside the kernel after the signature verification. So, but it's still in early stages, I would say, the whole work around this area.
Really interesting stuff. I think I saw something else on the list about BPF standardization, and I think it was from Dave at Microsoft. So presumably it's something to do with Windows and Linux and possibly other operating systems. Yeah.
We've been discussing this topic also at LSF BPF, like earlier, like beginning of the year, and we've made some progress ever since. The idea is to come up with a document that we can then put on the eBPF Foundation site, where we describe, different pieces of BPF. Right now, the idea is to start from the lower layers, such as BPF instruction sets. Which instructions do exist? How do they work? And what is the expectation around them? For example, not everything might be obvious to other platforms, right? In the case of the Linux kernel, just to give you one example, is the division by zero. So how should this be handled, right? And in eBPF, we cannot have exceptions because there's no such mechanism around that. Right now, what we implemented a few years back in the eBPF runtime in the Linux kernel is the same way how we do how division by zero is done in ARM64. Because typically if you have something like this, then the underlying architecture throws an exception. It might crash the kernel if you're in kernel space and do that. And
should this even get past the verifier? I mean, it would.
So we will reject programs where it's verifiable, where it's statically analyzable. But if it is not, you still need to handle that case, right? And so if you would throw an exception, or if you would just return with some invalid value, then you would be able to bypass the verifier, because, for example, when you have BPF to BPF calls, so function calls, then the verifier expects a specific return type. Could be a pointer or something else, right? And if you throw just an error, then that would violate what the verifier has been looking at, and you would then be able to do bad things with it. So the idea here is to not throw any exception at all, and to put the value into an invalid state in exactly the same way that ARM64 is doing. So that's just one example, right? But there are many other things that we need to document so that others can implement the same things. Yeah.
I mean, I guess the instruction set itself is probably pretty standard already, but so it's all this kind of machinery around those instructions and how those instructions are executed.
What are the semantics around them?
Yeah,
exactly.
Very interesting.
Yeah, and Dave has been helping to put this forward because Microsoft, they're using it for eBPF for Windows. There's also interest in not the non-software world. So people are trying to put eBPF into hardware, so they need exactly the same. An official document, which is signed off by the eBPF steering committee, helps here, right?
Yeah, fantastic. So yes, that makes the mind boggle about will we see hardware devices that only execute BPF programs? That would be interesting. Yeah. I see another one on the list here about BPF LSM for C groups, enabling more fine-grained policies. So we talked a little bit about that.
Yeah, so that one has already been merged. That was work that was ongoing by folks from Google. Essentially, they needed more fine-grained policies, right? Because BPF LSM is global to the whole system. Because the LSMs, they don't have a concept, they don't interact too much around the C group side. So this was a way to allow that. And they had to solve a bunch of different use cases. For example, one thing that I found interesting is, that you disallow certain containers to use IPv4 sockets. And because Google is going IPv6 only in their data centers, and to gradually allow for that, you need to have policy that disables that, but maybe not for other containers, right? Maybe others are not there yet, but those that are there, you want to disable it, or type of service, or various other things around networking mostly. To be more fine-grained there. So that's basically a mechanism where you have a specific LSM that is applied for a given container.
That could be really interesting, I think, for cloud native security. There's,
yeah, I totally agree. I mean, we might probably use it as well.
Yeah.
So it's a generic infrastructure. Everybody can take it away and implement something interesting that they need for their use cases. So yeah, that's really cool.
Fantastic. Folks, if you have questions that you're thinking about, type them in. We're getting relatively close to the top of the hour. So if you do want to ask a question, now is a good time. Are there any other sort of talks, either from our team or from others, that you think we should really mention?
Yeah, I think there's also XDP as an area that is seeing active development. So XDP is, that's the express data path layer of the kernel for networking, and it's where you execute a BPF program at the earliest possible point inside the network driver. And there are now two proposals. One is to bring queuing into this area, so that when you have, like, let's say, 40 gig interface where the traffic comes in, and maybe only 10 gig going out, so you need some kind of queuing mechanism. So apparently there's a need around that. The other one is also hardware acceleration. So how can you improve the existing set of XDP programs, for example, around load balancing or policy enforcement to protect against DDoS attacks, through a mechanism where you can get the information from your driver. And right now, this infrastructure hasn't been there, simply because there was an disagreement in terms of what kind of fields are needed from the metadata from the driver, and what kind of data should be exposed and how it should be exposed to the program. Just to give some examples, the network driver has various metadata around the packet, such as timestamps or like a packet hash that can be used, or the checksum of the packet. And right now in the XDP land, you have to calculate all of that by yourself. Some of this is, let's say, fairly expensive, especially when you have to deal with millions of packets per second. Then it gets costly. And if you can just, let's say, take the packet timestamp from the driver, because it provides it anyway already, then you can use that and speed up the program that you have slightly. So I think there's a good consensus to move forward with the proposal. It has been discussed for quite a number of years, and the development around this has been stalled a bit, but it seems it's being more active again. So yeah, that's great. And
sorry, go on. Yeah.
Oh, sorry. And yeah, I mean, there also has been talks around tracing improvements. For example, Alan from Oracle, he looked into the BTF data that has been generated for the Linux kernel, so that you get all the functions that are in data structures in the Linux kernel where you can attach programs to. And he was trying to find out whether there was a gap for BTF with Dwarf. So Dwarf is like the usual standard known debugging format. It is more complex and it exposes much more information than BTF. And he was trying to see whether there was a gap between the things, like especially functions that Dwarf exposes versus BTF. And there is a small gap indeed. So like a couple of thousand functions, they are not visible currently in BTF. And there was proposal how they are. So first of all, why they are not visible, because of some compiler optimizations. And then the question is, like how can you make them exposable to, so that you can attach something to it, for example, with BPF trace or BCC. But yeah, it's overall a tricky area, and the devil is in the details. But at least some of it makes sense to expose into BTF, and others where it's like, for example, inline functions where the compiler generates many entries with different suffixes. Maybe they make not too much sense to expose into BTF, because like really with BTF you want to have correctness first of all, because even the verifier uses BTF as part of the verification, right? So it has to be reliable and not, like in some areas a bit fuzzy. That would not be great at all. So yeah, so a lot of low-level topics there being discussed as well to then improve the infrastructure that is on top of it, right? So that's the whole. So not all of the topics being discussed there immediately consumable by users, but with the future set of applications, then they will be. So
yeah. Russell has a question that he may or may not know the answer to. What's the state of BPF in BSD?
Sorry, I have no idea. I really have no idea. I'm not following BSD development, so I cannot tell you. Yeah.
Fair enough. If anyone out there is following BSD development, then let us know. All right. So, like 2022 Linux Plumbers is now done. When do you start organizing for 2023? Is it every year for a start? Is it every year?
Yeah. That's a good question. I'm still super busy with 2022 because, there's eBPF Summit coming up with a lot of great content. After that, there's KubeCon. So I also have a talk for KubeCon around Cilium and some of the networking kernel development that we do there. So it's still super busy. So I'm still heads down 2022 before I think about 2023.
Yeah, absolutely. We are definitely into conference season. So
yes.
Yeah. eBPF Summit will probably be a good place to come and ask follow-on questions about things that you see if you go and watch some of these LPC talks. I know that a lot of the people who've presented at LPC will be involved in eBPF Summit as well. So there's a good chance you'll find them on the Slack channel. Even if they're not at the summit, there's a good chance you'll find them on the eBPF Slack, I think. So do come and join the Slack and ask if there are things that you've been intrigued by watching all those videos that Daniel has so diligently uploaded so quickly. That's great. Wonderful. So we're just about wrapping up at the end of the hour. Anything else that you would like to add, Daniel, before we close?
So yeah, I think it's super exciting to see so many development that is being put into the BPF community, whether it's now, like kernel community or the different applications around eBPF and in higher up in user space. So that's really exciting to see more folks being involved. And, it's a welcoming community. So everybody is, free to ask questions or free to submit patches. And it's a really nice and kind community also. So yeah, it's really exciting.
That's been a question that's come up a couple of times, whether or not, to me, whether people find the BPF community perhaps more welcoming than the kernel community has a reputation for. And my impression is that, things have improved across the board and that BPF is...
Absolutely. I think across the board, I think most of this, I would say, is, maybe a myth, but at least for the BPF side, it's a very kind and welcoming community and the barrier is really low. So yeah, fantastic. That's also, I think, probably well reflected with the rate of new developers that we see per month, right? That it's growing and growing constantly.
Yes, that graph we saw at the top of the show. People wouldn't be joining like that if it wasn't welcoming. Yeah. So speaking of being kind, there's a very kind comment from Russell, who's Thanking us for the screen. Thank you for watching. Thank you for your questions. Thanks everyone out there for saying hello. And with that, we'll wrap for today. And just a reminder, go register for eBPF Summit. See you there.
Bye.